Right now, as you watch this, something impossible is happening. Particles are communicating faster than light. Objects exist in two places at once. Time itself bends in ways that break every law we thought we understood. And here's what should terrify you. The smartest physicists on Earth, with billions of dollars in equipment and centuries of accumulated knowledge, have absolutely no idea why. We built nuclear reactors, sent humans to the moon, and created devices that fit the power of a supercomputer in your pocket. Yet the universe keeps showing us phenomena that mock our understanding. These aren't fringe theories or pseudoscience. These are documented, repeatable observations that have left Nobel laureates scratching their heads for decades. The foundation of reality itself contains cracks that we cannot seal, and what you're about to discover might change how you see everything around you. Double. Imagine throwing a ball at a wall with two holes. Simple, right? The ball goes through one hole or the other. But when scientists fire tiny particles called electrons at two slits, something impossible happens. The particles create a pattern on the other side that suggests they went through both holes simultaneously, like a ghost walking through two doors at once. But here's where it gets truly strange. The moment you try to observe which slit the particle goes through, it suddenly behaves normally. It picks one slit, as if it knows you're watching. Observation changes reality. This isn't science fiction. This is the double-slit experiment, first performed over 200 years ago and repeated thousands of times since. Richard Feynman, one of the greatest physicists who ever lived, called it the central mystery of quantum mechanics. We have no explanation. The particles seem to exist in a state of pure possibility until consciousness interacts with them. Some scientists believe this suggests reality itself is somehow connected to observation. Others think we're missing something fundamental about the universe. Either way, the implications are staggering. But this is just the beginning, because what happens when these particles are separated by vast distances? Spooky action. Einstein called it spooky action at a distance, and he refused to believe it was real. But experiments have proven him wrong again and again. When two particles become entangled, something that happens regularly in nature and laboratories, they form a connection that defies everything we know about space and time. Measure one particle and the other instantly responds. Not quickly, instantly. Even if they are on opposite sides of the universe. Faster than light. Nothing is supposed to travel faster than light. It's one of the fundamental rules of physics. Yet entangled particles seem to communicate instantaneously, as if the distance between them doesn't exist at all. Scientists have tested this phenomenon rigorously. They've separated entangled particles by kilometers and measured them with precision clocks. The correlation happens faster than any signal could possibly travel. Some researchers now believe that entanglement suggests space itself is an illusion, that at some deeper level, all points in the universe are actually connected. As physicist John Bell demonstrated, there's no hidden mechanism we've missed. The connection is real, and we cannot explain it. But if particles can exist in superposition and communicate instantly, what does that mean for time itself? Here's something that should keep you up at night. Every fundamental law of physics works exactly the same forwards and backwards in time. Drop a ball and it falls. The equations that describe this work perfectly if you reverse time and watch the ball rise. Particles colliding, planets orbiting, light reflecting, all the mathematics works in both directions. So why does time only flow one way for us? The distinction between the past, present, and future is only a stubbornly persistent illusion. We remember yesterday but not tomorrow. Eggs break but never unbreak. Coffee cools but never spontaneously heats up. We call this the arrow of time, and physics has no explanation for why it exists. The universe at its most fundamental level doesn't care which direction time flows. Yet here we are, trapped in a one-way current toward the future. Some scientists point to entropy, the tendency of systems to become more disordered. But this just describes what happens. It doesn't explain why. Why forward, never back? We experience time so intimately that we assume science understands it. But the more deeply physicists probe, the more mysterious time becomes. And speaking of things that shouldn't exist, What about the invisible substance that makes up most of the universe? Invisible. Look at the night sky. Every star you see, every galaxy astronomers have photographed, every planet and asteroid and cosmic dust cloud combined represents only about 5% of what exists. The other 95% is completely invisible, and we have no idea what it is. Scientists call it dark matter and dark energy. These aren't just clever names for things we understand. They're admissions of profound ignorance. 95% unknown. We know dark matter exists because galaxies spin in ways that would tear them apart without additional mass holding them together. We can see its gravitational effects bending light around galaxy clusters. It's as real as the chair you're sitting on, but we cannot see it, touch it, or detect it directly. Dark energy is even stranger. It's an invisible force accelerating the expansion of the universe, pushing galaxies apart faster and faster. Every second, the cosmos grows larger at an increasing rate. And despite decades of searching with the most sensitive instruments ever built, we have found nothing. No particle, no field, no explanation. We are surrounded by a universe we cannot perceive. Our entire understanding of reality is based on the tiny fraction we can actually observe. But wait, because what if the mystery isn't just what we can't see, but why there's anything to see at all? Why? When the universe was born in the Big Bang, equal amounts of matter and antimatter should have been created. They're perfect opposites. When they meet, they annihilate each other completely, converting into pure energy. By all the laws of physics we know, the universe should have destroyed itself in the first fraction of a second. Matter and antimatter should have met, canceled out, and left nothing behind but light. Nothing should exist. Yet here you are. Stars burn, planets orbit, life emerged. Something tipped the balance, creating slightly more matter than antimatter, leaving behind the universe we inhabit. And physics cannot explain what that something was. This is called the Barrian asymmetry problem, and it haunts cosmologists. For every billion antimatter particles created in the Big Bang, there were 1,000,001 matter particles. That tiny asymmetry, which violates the rules we observe in laboratories, is why anything exists at all. As physicist Lawrence Krauss once noted, the universe is the ultimate free lunch. We are living proof that something impossible happened. The very fact of our existence contradicts our equations. And if the birth of the universe defies explanation, what about the fundamental force that holds you together right now? Gravities. You feel gravity every moment of your life. It keeps you on the ground, holds the moon in orbit, shapes galaxies across billions of light years. It's the most familiar force in existence, and we have no idea what causes it. Newton described how gravity works with beautiful mathematics. Einstein refined it further, showing that mass bends space and time themselves, but neither explained why mass warps spacetime in the first place. The mechanism remains completely unknown. The why remains hidden. Every other fundamental force has been explained by particle physics. Electromagnetism works through photons. The strong nuclear force works through gluons. The weak force has its own carrier particles, but gravity refuses to fit this framework. The theoretical graviton, the particle that should carry gravitational force, has never been detected. Worse, when physicists try to combine gravity with quantum mechanics, the equations produce nonsense, infinities that make calculations impossible. Our two greatest theories of physics are fundamentally incompatible. One describes the very large, one describes the very small, and they cannot be reconciled. We are missing something profound about the force that shapes the universe. But gravity isn't the only familiar thing hiding deep mysteries. What about consciousness itself? Consciousness. Right now, you're experiencing something. There's a felt quality to reading these words, to hearing this voice, to being you. This inner experience, what philosophers call qualia, is the deepest mystery science has ever confronted, and physics offers no explanation whatsoever. The hard problem of consciousness is the problem of experience. We can map every neuron in a brain. We can trace electrical signals and chemical reactions. We can build computers that process information faster than any human. But none of this explains why there is something it feels like to be you. Physics describes objective reality, particles bouncing off each other, forces pushing and pulling. But your subjective experience, the redness of red, the pain of pain, the taste of coffee, exists in a realm physics cannot touch. Experience defies equations. Some scientists argue consciousness is an illusion. But an illusion for whom? The very concept of illusion requires someone to be fooled, and that someone has conscious experience. We are aware beings in a universe made of unconscious matter. How awareness arises from atoms remains completely unknown, and this brings us to perhaps the strangest implication of all these mysteries combined. Measurement. Remember the double-slit experiment. Particles exist in a blur of possibilities until observed. But what exactly counts as observation? Does a camera count? A computer? Does the observer need to be conscious? Physics has no answer. This is the measurement problem, and it strikes at the heart of what we call reality. What makes reality real? The mathematical equations of quantum mechanics describe particles as waves of probability. Every possible outcome exists simultaneously in what's called superposition. Only when measurement occurs does the wave collapse into a single definite state. But the equations never define what measurement means. Erwin Schrödinger illustrated this absurdity with his famous thought experiment. A cat in a box with a quantum trigger is simultaneously alive and dead until someone opens the box. The math suggests this is literally true, not just a limitation of our knowledge. I do not like it, and I am sorry I ever had anything to do with it. Different interpretations of quantum mechanics offer wildly different answers. Maybe consciousness collapses the wave. Maybe every possibility spawns a new universe. Maybe the wave never collapses at all. We simply don't know. And this uncertainty extends to something even more fundamental. Fine-tuning. The universe runs on numbers. The strength of gravity, the mass of electrons, the speed of light. These fundamental constants appear to be arbitrary. They could have been different. But here's what's deeply strange. If any of them were even slightly different, life as we know it would be impossible. Change the strength of gravity by 1 part in a billion, and stars either burn out instantly or never form at all. Alter the electromagnetic force by a tiny fraction, and atoms cannot hold together. The universe appears impossibly fine-tuned for complexity and life. Precision beyond chance. Physicist Roger Penrose calculated the odds of our universe having the right conditions for life at 1 in 10 to the power of 10 to the power of 123. That number is so large it exceeds the total number of atoms in the observable universe by an unimaginable margin. Some invoke the multiverse, infinite universes with random constants, and we exist in one that happened to work. Others see evidence of design. The universe is not only queerer than we suppose, but queerer than we can suppose. Physics cannot tell us why the constants have the values they do, or why our universe is so improbably hospitable to existence. But this leads us to the deepest question of all. Limits physics. Here is what all these mysteries reveal. Physics is not a complete picture of reality. It may never be. We've built particle accelerators miles wide and telescopes that peer billions of years into the past. We've formulated equations of extraordinary precision that predict outcomes to dozens of decimal places. And yet the most fundamental questions remain unanswered. Knowledge reveals ignorance. What is time? What is consciousness? Why does anything exist? Why these laws and not others? Physics describes how the universe behaves with stunning accuracy, but it cannot tell us why. Every answer leads to deeper questions. Every solved mystery reveals 10 more unsolved ones. Some believe a final theory of everything awaits discovery, an equation that explains all phenomena. Others suspect certain truths will forever exceed human comprehension. Perhaps we are like fish trying to understand fire. The more I learn, the more I realize how much I don't know. But here is the profound truth hidden in these mysteries. The universe is far stranger and more wonderful than our everyday perception suggests. Reality is not the solid, predictable thing it appears to be. It shimmers with possibility, holds depths we may never fathom, and reserves secrets that humble even our greatest minds. These 7 phenomena aren't just scientific curiosities. They're cracks in the foundation of everything we think we know, particles that communicate instantly across the cosmos, time that flows in only one direction for no known reason, a universe made mostly of invisible matter and energy, the impossible fact that anything exists at all, gravity we feel but cannot explain, consciousness that observes but defies description, a cosmos so finely tuned that chance seems insufficient explanation. Together, they tell us something profound. Humility is the only honest response to existence. We are small beings on a tiny planet, reaching toward mysteries that may forever exceed our grasp. Yet that reaching itself is magnificent. The questions matter as much as the answers. And perhaps that's the deepest lesson physics teaches us, not that we know much, but that we know enough to recognize how much remains unknown. The universe didn't owe us comprehensibility. The fact that we can understand anything at all is itself a mystery worth celebrating. So the next time you watch a sunset or feel gravity's pull or simply experience being conscious, remember, you're participating in phenomena that the greatest minds cannot explain. You are part of the mystery. If these mysteries made you think, hit like and subscribe. What unexplained phenomenon fascinates you most? Tell me in the comments.